Yep.
Okay.
There we go.
All right. Okay. So thanks very much for inviting me to talk today. And I thought I would talk about my two favourite subjects, which is landscape ecology and ecosystem services, two areas which I've worked on over the last 15 years or so, or even longer. But you know, I will put a health warning on this. Is that, similar to Rich, I don't really work on infectious diseases. I have one or two papers looking at infectious diseases, but really it's not my area of expertise. But what I do is work on tackling spatial problems, and I largely come from a sort of background of landscape ecology and thinking about spatial problems at large scales, at least landscape scales. And I'm really interested in understanding how and how much nature benefits people as well. And a lot of the work that I do is framed around sort of using concepts from ecosystem services to do that. So, and all of my work is highly quantitative, and I use modelling to address some of these questions. But what I thought I'd do is really talk about, have a bit of an overview of sort of some of the concepts from landscape ecology and ecosystem services, and really, I guess, indicate, perhaps avenues for thinking about how these ideas might help in trying to understand infectious diseases. But as I said, I'm not an expert, so I may say some stupid stuff, but that's okay. Forgive me. Okay, so what I thought, well, let's have a look. I mean, so in terms of coming from a sort of landscape ecology, conceptual background, so what is landscape ecology? Well, really, it's the science of studying the relationships between spatial pattern, and there seems to be some bits missing from the, maybe not, oh well. Spatial pattern and ecological processes. So what we're really interested in is trying to characterize patterns of landscapes and characterize those patterns at multiple scales. So at landscape scales or larger, but also at finer scales as well. And using that with modelling and to compare all the data to infer the consequences for ecological processes. So we're interested in this nexus between pattern and processes. So trying to infer what's happening in terms of those ecological processes. And that's really and I think landscape ecology really has, one of the major contributions is really, and certainly in the early parts of landscape ecology, was how do we actually describe landscapes? So, and that was one of the first challenges, I guess, when it first started to evolve. And so we have a bunch of ways for trying to do that. And then coming on from sort of Colleen mentioned this, but I guess spatial epidemiology is maybe a subfield or an extension of landscape ecology, and really with the idea of trying to take this idea of looking at the structure of landscapes and trying to infer processes, but for disease processes like spread and so on. And so landscape or spatial epidemiology really, it tries to explain spatial patterns and processes of disease at that landscape scale using spatial explicit measures. And trying to link things like landscape structure to vector and host distributions, but also those human incidents and so on, and the sort of human side of things as well. And I think landscape ecology really can provide some of the conceptual basis for characterizing those landscapes. And we typically think about landscapes in terms of two dimensions. One is composition, so what's the landscape made of? What does it consist of? What are the elements? And the other is the configuration. So how are those elements in the landscape spatially arranged? So what are the locations of those elements? And I just thought I'd give you one example. So I said I don't work on epidemiology, but I have done a couple of papers, and I'm going to mention one now, which came out. And I didn't lead this, but this came from a nice collaboration with Paola Prest and Jean-Paul Metzger, who were here a couple of years ago on sabbatical. And I think this is a nice illustration of how we might think about landscape pattern and how this relates to disease spread, and a nice illustration of how we might use some of those concepts from landscape ecology. So this was a study looking at yellow fever spread in São Paulo state in Brazil. And really we're interested in trying to understand, well, what are the landscape level drivers of spread? And they had data on yellow fever incidents in non-human primates. These are howler monkeys. and the spread across a portion of Sao Paulo state. And the approach we took was to first of all develop a network. Okay, so thinking about, so we have this data on spread, we're able to develop a network of the transmission, and then use an approach called circuit theory, which characterizes resistance across the landscape, and statistically then link the data on the spread through the network with this idea called circuit theory. Circuit theory actually was developed originally for understanding electrical networks and the movement of current through the networks, but it can be applied to landscapes equally. And it allows us to basically understand, well, what are the key landscape features that might drive that spread? So statistically, we're able to find, I mean, I guess just some of the main findings were that really the facilitators of spread of yellow fever in this case was forest edges, particularly adjacent to urban areas and agricultural areas, but also roads adjacent to forests. So getting some key insights into, at the landscape level, what might drive spread. And so this, this is useful because it provides us with some insights into what might make a suitable landscape. If you're thinking about landscape design, suitable landscapes for limiting that spread. So we're able to come up with some recommendations around how might you design landscapes to minimize that spread. So avoiding forest, trying to minimize forest edge, for instance, avoiding roads through forest and so on. So I think that's quite a nice example of how you might apply some of the ideas of landscape ecology to infectious diseases. But that's the only paper I've ever really written on infectious diseases. So that's sort of what I was going to say about landscape ecology. But then the other area where I work is in ecosystem services, and really ecosystem services is a conceptual idea around trying to capture, trying to measure and assess the benefits people receive from nature that contribute to their well-being. So it's a very human-focused idea. And most ecosystem frameworks have probably three broad classes of ecosystem services. So these are provisioning services. These are the food and fiber that we get from things like agriculture, regulating services like climate regulation, generation of clean water, and then cultural services. So these are the cultural benefits we get from things like green space. So a lot of the green spaces Rich was talking about provide health benefits, but they also provide cultural benefits, right? And there's lots of examples of cultural benefits, culturally significant areas and so on that depend on nature. Disease regulation is really a regulating service. So if we're thinking about the contribution of nature to disease regulation, then it comes into that regulation, regulating services. And so what ecosystem services does is really allows us to think of that human-centered approach. And we're really interested in trying to capture the actual benefit of nature. And in terms of infectious diseases, it might be how does nature regulate or reduce the incidence of disease. But also this is a sort of a paper by Paseka, also highlighting that actually infectious diseases can interact with other ecosystem services. And so there's an interaction here as well that might affect human well-being indirectly. So some of the things that we've been doing over the last few years, 5 years or so, is trying to think about the ecosystem service concept in a spatial context. This is trying to link landscape ecology and ecosystem services. And the conceptual way that we've been thinking about this is really around this thing called the ecosystem service provision chain, where we have the supply of a service. So this might be, it might be a green space, for instance, and then we have demand for that service. And so that might be human demand for that service. And then there's this flow that links the two. And this flow can be spatial. In a spatial context, it could be the movement of people or organisms, pollination, pollinators, for instance. And it's this connection that generates the service. Without the demand, you don't get any service. So it's this connection between the human and ecological aspects that's critical, that generates the service. And we recognize that actually landscape structure is critical in driving both in a landscape the supply of that service, that potential benefit to people, where the demand for that is, and where the flow is as well. And we think, we can think about this potentially in terms of infectious disease as well. And work that we've been doing recently as well, again with Jean-Paul Metzger, was thinking conceptually about what are the types of patterns and the consequences of thinking about it in this way spatially. And so this just shows the green dots are sort of the supply areas of a service. There might be a green space, and the blue areas are the demand for that service. And so, and trying to think about, well, what are the ways in which configuration and arrangement spatially might drive the benefits people get from nature. And then we've been thinking also about how we might measure that. So these are just some examples of sort of hypothetical examples of fragmentation of both the demand side, the social side of the ecosystem service generation, but also the ecological side, the supply patches, and thinking about how these different metrics of landscape structure might drive networks and therefore the benefit people get from nature. And so there's also the interlinkages between these supply and demand areas. So that's some of the sort of work that we've been doing. But to come back to disease regulation, I guess these conceptual ideas provide us some ways to characterize landscapes and conceptualize and assess the consequences for the benefit of nature to people. But if we think about disease regulation, this is just a hypothetical example where perhaps just put it out there to you to think about in terms of thinking about how we might measure the ecosystem service benefits of nature in terms of disease regulation. And so this box, imagine this box is just the amount of disease in a landscape, and part of it might be regulated by nature. This might be the amount of biodiversity in the landscape and so on. Some of it's not, right? So some of it is not reduced by nature, and that might require other interventions. But at the same time, some of the population are exposed to the disease, but some are not. Okay, so you have this blue area in the middle, just conceptually representing the exposed population. The black areas above and below are not exposed. Maybe they're vaccinated or they're not in a particular area that's exposed to the disease. And then this purple area really is just the realized benefit from nature. And then there's a gap, right? So there's a component that's not benefited from nature. There's no benefit from nature, so it's a gap. And so this is just really trying to capture conceptually how might we start to think about the contribution of nature in terms of, say, regulating disease, and what's I guess the gap in terms of other interventions we may need that are not addressed through nature. And then we can build on top of that this idea of the social ecological landscape structure, and this needs to be underpinned by those spatial models. So it's really just and this is an approach used by ecosystem service assessments, is try to think about it in this way. So it may apply also taking a human-centered approach to thinking about infectious disease. Okay, and I'm going to leave it there. Thank you very much.